Okay, hi, this is G.K.SHAAM from IT department. Okay, this is Max Engineering Mathematics Part 2 assignment. Lagrange multiplier. Lagrange multiplier method is a technique for finding the maximum minimum values of a functions subject to constraint, where f of x by z is a function under constraint is phi x by z. The Lagrange equation is given by g is equal to f plus lambda times phi. To solve Lagrange equation, these are the steps. Step 1, we should write a Lagrange equation. Then step 2, we need to we need to compute the partial derivation and put them to 0. Actually, by doing this, after this, we should find x, y, z in terms of lambda. That's the step 3. After doing that, in step 4, substitute back the constant. You have to substitute back the constant. Then step 5, find the points. Step 6, evaluate with each point. After evaluating, we will get the points maximum and minimum. Okay. This is what Lagrange multiplier is. It's basically about finding the maximum and minimum values of a function which is subjected to a constraint. Let's see some examples. First exercise. Find the minimum of a function f x plus 3y plus 5z subject to the constraint x square plus y square plus z square is equal to 1. Here, first, Lagrange equation. We should write x plus 3y plus 5z minus lambda into x square plus y square plus z square minus 1. Now, put the partial derivative for x, we get this equation. For y, for z. Now, substitute this function in the constraint. This is what we get. After solving this, we will get the lambda value plus or minus of root 35 by 2. Now for each case we'll do. In case of plus, we'll get these x, y, z values, which is 2 into 35, root 35 by 2, 2 gets cancelled. You'll get 1 by root 35. Y the same case goes, but since here it's split 3 by 35, and z we have 5, so it will become 5 by 35. Next, for lambda is equal to minus 35 by 2, since it doesn't have any major changes, just the sign changes. Minus 1 by 35, minus 3 by root 35, plus 5 by root 35. Now, let's put this x, y, z values in the function. Now, for the positive ones, for lambda is equal to root 35, the x, y, z values we get, substitute these in, then the function, the f value you get 1 by root 35 plus 3 into 3 plus 5 into 5. Root 35 is common, so put it aside down. It becomes 1 plus 9 plus 25. 9 plus 1 is 10. 10 plus 25 is equal to 35. Since root 35 into root 35 is equal to 35, we will put this 35 by 30, root 35 will becomes root 35. Now, for minus 1, for minus 1 by root, for x is equal to minus 1 by root 35 and minus 3 by y is equal to minus 3 by root 35 and z is equal to minus 5 by root 35. For this, the f value will be minus 1 minus 9 minus 25 divided by whole divided by root 35, which comes minus 35 by root 35 is equal to minus root 35. Hence, the maximum value will be the root 35, which the points are 1 by root 35, 3 by root 35 and 5 by root 35. And the minimum value would be minus root 35 and the points will be minus 1 by root 35, minus 3 by root 35 and minus 5 by root 35. Now we have found the maximum and minimum value. They ask us to find the minimum value. Since the minimum value is minus root 35, we find the answer for this question. This is how we use Lagrange method to find a minimum and maximum value of a function which is subjected to a constraint. Thank you.